Okay, so for today, we were supposed to look at kind of the differences between 2D and 3D games. Because, I mean, so in here, we're going to be doing 2D stuff. In the next course, we're going to be doing 3D stuff. And then towards the end here, or maybe even the last 25% of the class, we'll start rotating over to 3D, depending on how quickly we get through the early genres of our 2D games to just kind of because I think something that we're going to do, and you want to think back to the games of your when you were younger, let's say, we're going to look at games like Mario Brothers, like Zelda, like maybe like a space shooter, Asteroid Galaga type thing. Just thinking about the and all of those you can like play on in a web page these days. But thinking about what went into games like that, what are the different mechanics that play into it, and really breaking it down to those the primitive aspects of it. Because I mean, at the end of the day, when you're playing a video game, it's all about faking out the user, right? Same thing's true with operating systems. We connect it to that. When we think about an operating system managing our CPU, well, what's the ultimate goal? I mean, if back when we had single core CPUs, the CPU can only do one thing at a time. But as humans, we're very, very demanding. So we have 5 or 6 different applications. What do I have open here? I have all these applications open on my machine right now, plus a whole bunch of crap running in the background. Let's see what's running on the background of this machine right now. Yeah, so here's all these different applications that are running back there. Here's this is the thing that's running the network. MD worker, I wonder, that's probably a thread for some application. Do I have any application that MD makes sense for? The M might stand for Microsoft. There might be something with Visual Studio. Well, I guess we can find out. Let's see if those MDs disappear. Nope. So bottom line is there's a whole bunch of applications here that we maybe don't even know what they're attached to. There's all this stuff running behind the scenes in our operating system. And then up top here, we kind of get an idea of, how many total processes are running, programs are running on our computer. With 413. Way more than you see in this list, right? 2 or 3 are running at one time. This is what's on the CPU right now. What's actually getting CPU time? Okay, a majority of these guys are sleeping. They're in the background. They're not getting any CPU time. But the reality is they are getting CPU time. They're just getting it. The CPU is constantly switching between one application, another application, another application, another application, and our processor is so fast that we don't notice. We don't care if they're actually happening at the same time as long as we think they are. Right? Same thing's true with games. You might have a situation in a game where you might say, okay, well, I want this guy to be able to run into this guy. When this guy hits this dude with the sword, bad things happen, right? The guy gets hurt. Well, now you have this situation, well, if you try to be too precise with that, we're going to see ways of accomplishing this with our games. It takes a lot more processing power than if you come up with a little trick for how do you mimic that collision in such a way that it's not taking all sorts of processing power to deal with that collision at like the pixel level. Maybe you just put a big square at the end of the sword, and if that square hits the thing that you're trying to hit, that's good enough. Instead of worrying about in real life, if any part of that sharp blade hits you, we're dealing with problematic situations, right? But in a game, everything's happening so quickly and we're not worrying about death and all this other stuff. We don't care as long as we're faked out. In fact, we would care if it was sluggish, right? We'd rather it be inaccurate, but mostly accurate and fast than completely accurate and sluggish. So a lot of what we're doing in game design comes down to faking out the end user or coming up with something that looks right, even though maybe under the hood we know it isn't quite matching reality. Does that kind of make sense? All right, so now if we're comparing 2D versus 3D games, what are some of the things that go into that? What are the differences? What did we find were the kind of the core differences between 2D and 3D? Don't all speak at once. Go ahead.
You have differences when you're making your models because 3D has a lot more polygons.
Okay. So 3D, or like us, right? So and if everything's made up of polygons, it used to be triangles, now they can be more complex shapes, but if everything's made up of all these things, we have all these layers to create, what's supposed to be a kind of a smooth curve looking thing around. Where if we have 2D, it's just a picture, right? It's a flat picture. And they're usually called sprites. Okay, when we're talking about 2D stuff, these guys are called sprites, and we're going to talk a little bit about sprites today. Okay, so certainly a difference in our the way we generate our character models or something like that, the art that goes into the game. Now, a lot of times from a programmer's perspective, we're going to rely on our art being created by somebody else. Maybe in the early days, if you're just kind of screwing around, and Unity has some tools for this where we can kind of bring primitives in. They're actually not very good about this for 2D stuff. 2D was added to Unity at a later date. So Unity has 3D primitives, so we can like drop a sphere or drop a cube into the scene, and that could just be our bad guy. You have a sphere fighting a cube. Or you have a green sphere fighting against a yellow sphere, and those are the good guys and the bad guys. And then once you kind of have the mechanics working, then you can decide, okay, let's make our guys not look like spheres, because that game would not sell well probably. But they don't have quite the primitives for sprites. They do have a sprite primitive, but it doesn't look like anything. You'd have to attach some sort of picture to it. Not the end of the world, but it's one extra little step you have to go through. But in any case, as a game designer, we might not actually create our own art. So in the game programming major, the classes, some of the other classes you'll take are like the animation classes, where you'll actually be generating models and also generating the animations. What we'll do in here is we'll use existing models and build the existing models that have the animations, and then we'll put those animations together. And typically what I'm saying, especially in 2D game design, when we're talking about animations, we effectively have a series of, if let's say you have a character that is just sitting there idle. Okay, but instead of idle being just completely still, he almost seems like he's breathing. He's kind of just moving just a little bit to look alive, right? Now, that might be a series of, let's call 6 or 8 images that when you play them right next to each other at, some sort of reasonable speed, the guy looks like he's breathing or sitting there moving back and forth. He feels alive. Okay, but effectively all it's doing is it's changing from picture to picture to picture to picture over some number of frames to make you feel like it looks alive. And then you can change the speed of the animation if the guy is breathing too quickly or really slow motion. Just the guy seems like he's like a zombie or something. You can change some of those things. But that's how we'll build our animations with sprites. Is effectively you have several pictures that are basically the same picture with slightly different positions of maybe the arm or something like that. And when you play those next to each other, it looks like something's happening. No different necessarily than if you've ever done the whole flip book thing. All right. So that's what our animations will look like. When you get into 3D stuff, you can do animations in that same way. But a lot of times what you actually want to do is you want to pre-render your animations. Because now when you're dealing with all of those, she mentioned polygons. Okay, so all of our art in our game is made up of a whole bunch of, let's just use the old school triangles. Okay, even though we can be more complex than that now. But, the more triangles, the smoother the surfaces look. Okay, so the idea would be that if you have a zillion triangles that you're having to, show on the screen at one time, and you're having to use part of your computer's processing power to calculate the difference between having, let's call it 1,000 triangles in this configuration versus 1,000 triangles in a slightly different configuration, that takes quite a bit of processing power. If we pre-render that, where effectively our 3D model is almost like a standing video. Okay, so instead of us rendering a each of those triangles at a frame rate, we are instead watching a video play out. And this is just a moving video on the screen. Does that kind of make sense? Kind of oversimplification, but effectively what we're doing is we're rendering that animation one time. And it might take quite a long time to render the animation, depending on how smooth you want it to be. I mean, it could be something that takes 3, 4, 5 hours for even a somewhat simple animation that has a reasonable amount of detail. But once it's cooked, think of it like baking cookies. Okay? Once that guy's baked, then you can bring it into your project, and now it just plays the movie when it wants to do the animation. That makes sense? Okay, so certainly the difference in character models. What else is different when we deal with 2D versus 3D? Go ahead. Okay, certainly game size, and that has something to do with the models. We have, we certainly have a higher expectation. We would say our 3D games are evolutions of our 2D games, right? So years and years and years ago, we had 2D stuff like Mario. Well, now when the newest Mario comes out, it's definitely a 3D world, right? And part of that's because the hardware has caught up. It's more capable. Where you have for Mario it would be on the Nintendo. So you have the latest Nintendo. What is the current one? Wii U. No, the currently is the Switch, right? So you have the Nintendo Switch. What's the if they released for the first time the original Super Mario Brothers, 2D platformer, you probably wouldn't be overly impressed, right? Even though that was like the coolest game ever once upon a time. All right, we expect more from our stuff today because the hardware is capable of it. All right, what else? A few minutes ago, we talked about that whole faking out thing, right? If we're trying to fake stuff out in 3D space, we have potentially more complications, right? Because there's more sides of our character that potentially are interacting with the world. If we have a sprite, this is a flat picture, okay? He doesn't have a fat side over on this thing that might be bumping into bushes and trees and fences and things like that. He's just a picture that's moving along. In fact, usually we're thinking about it in terms of layers, right? We have kind of a background layer. That might be our, if you think about Mario, that's kind of like, the sky and stuff like that. That's just a picture. Okay, and sometimes that doesn't even move. Okay, because back then with older hardware, you want that to be kind of static, so you're not having to change the position of clouds and things like that. All right, you'd rather have where the action is be important. Okay, and we're actually seeing that in modern game stuff kind of make a comeback because now we're, we did talk about resolution and things like that, didn't we? Okay, so kind of a modern trend today in our games is this idea of 4K gaming. Okay, which means our games are playing at a full 4K resolution, which is four times 1080p. Super high definition. Well, that means that we have a lot of pixels that we need to drive at 60 frames a second, let's say. And what we're seeing now is, we're seeing this move towards virtual reality. Now, the problem with virtual reality, right now virtual reality is running at about 2K. But when you do virtual reality, we don't necessarily think about it like this, but you're actually having to drive 2 monitors, and really 3 monitors, because you have the computer monitor the VR helmet's connected to, and then you have the game running on the 2 lenses, 1 per eye. And each one of those is an independent monitor. So if you want to drive this thing at 4K, let's just push the envelope. We have a 4K screen here that we're needing to run at 90 frames a second. Okay, for VR, you find that 90 frames a second, as opposed to a slower speed like 60 frames a second, it kind of fights against nausea. This one issue you have with VR is motion sickness issues. So now you want to drive this at 4K at 90 frames a second, this at 4K at 90 frames a second, and believe me, when I say 4K at 90 frames a second, that's not easy. Okay, driving 4K at 90 frames a second requires some horsepower. In fact, This statement is only going to last for so long because every 5 seconds there's going to be new games coming out. But right now, one of the in virtual reality, one of the most complex games that's out is a game called Robo Recall. It's for the Oculus Rift. Facebook spent zillions of dollars to have this game created, and it's free when you get the Oculus Rift, because the idea is that Oculus was kind of the original cool kid in VR, that it lost some of its shine because it didn't have motion controls. They came out about 1.5 years too late. But then once they came out, they released Robo Recall alongside it for free, and it's made for the motion controls, and it's really good. Yeah, it's done really well, and you can tell that Facebook, who owns Oculus, spent buku dollars on this thing. Well, there's only like 2 graphics cards in existence today that can drive Robo Recall at 90 frames a second at 2K. Okay, and they're basically the same card. It's the NVIDIA 1080 Ti, or the what's the other card? Titan X. Same card. Let's call it the same guts. So you have 2 graphics cards that are the most expensive graphics cards. That is probably not the graphics card that everybody who has VR has in their system. Probably your most common graphics card that people have in their system, if you have a high-end system for VR, would be like a 1070 NVIDIA card. That's the one that makes like the most price sense. It's significantly less expensive than the 1080, but not that much more than the 1060. And the 1060 is considered like the bare minimum for VR, like good VR, let's say. So 1070 is like your sweet spot if you don't want to break the wallet, but you still want to have really good VR for the next couple years, let's say, before the games start outpacing it. But we're already seeing an example of a game that will not run at 90 frames a second on a 1070. Okay? And it's just floating around 90 frames a second on a 1080. We're talking 88 to 92. We're right at that envelope. So when we start talking about 4K gaming, we're having to move a whole lot of stuff at one time. And the more complex the world is, if the world has depth to it, we have a lot more stuff we need to show. So what they're starting to do in VR is they're starting to do something called eye tracking. Have any of you read about eye tracking at all? Okay, do you know what it is? What is eye tracking?
Basically, they're paying attention to where your eyes looking, so they know where to focus.
Yep, which is kind of like how real world works. Your brain, whatever you're actually focusing on, is a lot clearer. If you kind of try to look at your peripheral without actually focusing at your peripheral, because I don't bring it into focus, you can kind of see that everything over there is fuzzy, right? Okay, so your brain is only really rendering, at the highest resolution, what you're actually focused on, because that's what you're paying attention to. Who cares about the fluff? Okay? You kind of want to know the rough shapes. Like if you're driving, you want to know the cars are over there. Okay, but you don't need to know necessarily what their license plate says if you're looking straight ahead. The fact that they maybe sort of kind of have a license plate is probably good enough. That means you're dealing with a car at a high enough detail that you probably could avoid it. Right? So now we're trying to bring that stuff into our games today. Where historically, and this is definitely the case for 2D games, everything that would be on the screen at one point in time. Okay, so if you have a game world that's on your screen right here, it's not going to spend time rendering something that's out over here, or rendering something you've already passed out over here. Okay, those things will become rendered once you kind of get to there, once it enters the pixel field of your screen. Okay, but other than that, everything that's actually potentially visible by the user, even if you're not looking at it, everything that's potentially visible is getting CPU time, getting GPU time, taking away from your overall performance. Okay, so if we can introduce eye tracking into our desktop gaming, we can make a big jump in, let's call it performance, but chances are that's not what will happen. We would keep the performance alone and just make a big jump in resolution and graphic texture quality. At some point we're going to be dealing with stuff that looks more real than real. You already kind of have that problem in some games where when a game tries to look too real, it kind of gets that creepy vibe. You kind of know what I mean? It's like it's something about it doesn't look natural. Or nobody sits there and says, Mario just doesn't look real enough. Mario's a cartoon. right? And we're saying that's good enough, and we actually see it in a lot of different examples. A lot of the popular, so let's take games like World of Warcraft, or what are some of the MOBAs? Um, Dota. These games, the characters are much more cartoony, or medievally, knights and stuff like that, as opposed to trying to look like a real person. Okay, part of that is it's easier on the rendering engine, but some of those models are pretty detailed, so it's not necessarily easier. Showing there's a current game called Rust that's out. It's a 3D game. That's we got there's a new genre of games kind of called, well, not new, but newish. They're survival games. Well, Rust just dumps you out in the wilderness naked, literally naked. So they're not having to render clothes or any of this stuff. So there's not that much stuff. And I'm not sure why they went to this extent, but it's anatomically correct. I'm not sure, at what point did they just decide that was required? But, in any case, even though they're trying to make it look very, 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 very real, that's actually simpler than a cartoony model that's very detailed. Okay? But the cartoony models end up faking out the end user. Okay? If we're playing it and we're looking at it, we're not judging whether or not the graphics look real enough. We're judging just based on if they look cool, right? You're playing some space shooter game or something like that. We're not thinking about the physics of whether or not this thing could actually exist. It's like, that's a cool ship. They always have these ships that have these weird like tentacle things. Like all the alien ships have tentacles and stuff coming off, like stuff that doesn't make sense. Like those things would so easily break off, right? Like who builds a spaceship like that? Oh, the aliens would. Doesn't make any sense. But we don't care because it looks cool. And we're fine with that. All right, so our modern games today are showing everything that's on the screen, and we're starting to see that transition towards, which is kind of evidence of where our hardware is, that we want to push our games to the next level. The hardware isn't quite keeping up with that, because our expectations are so high as opposed to the hardware really sucking. Although I think we mentioned this a little bit, maybe the first or second day of class, dealing with AMD versus NVIDIA graphics cards, where really AMD has lagged behind pretty substantially. Because right now, all the talk with AMD is in their new cards are just coming out with now, which are basically as good as the cards from NVIDIA from 2 years ago. There are some very specific tasks that the new AMD cards are as good or better than the 1080. Very specific tasks. So, it's not like they completely suck. Let's call it AMD has caught up, but it took them 2 years. They were dragging for 2 years. So we're really sitting at, let's call it somewhat of a wall for our GPUs. I'm sure we'll blast through it here before too long, start having quantum GPUs or something like that. But the punchline is we're sitting here kind of at some sort of wall with our GPUs, and we could throw more cores in it and figure out how to cool it and things like that, and that'll give us some more performance. But eventually we're not going to have giant leaps in performance forward probably for the next year or two. Now, with that in mind, now it's a matter of let's squeeze as much out of what we have as we possibly can. So, in VR, we're doing eye tracking. So now maybe with our, most of our computers have cameras on them so they can do eye tracking with that. So now whatever you're looking at on the screen, that's going to be the 4K stuff. And everything else is going to be grayscale or something like that. That would actually be probably a pretty interesting effect for a game. If what you were actually looking at was full color 4K and everything you weren't looking at was literally grayscale, it would have an interesting effect from when you look around the screen, seeing things come into color and yeah, I don't know. Huh? Yeah, but I think that's kind of the point. Yeah. But it would be interesting whether or not, you might get motion sickness from it. Because now you're dealing with that, with the Wizard of Oz effect, but over and over and over and over again. Because Wizard of Oz was the first third of it was in black and white. Then it became Technicolor, right? I think that was the official name of the first whatever. Okay, but when we're dealing with 2D games, certainly, and even 3D games in our computers today, everything is rendered that's visible on the screen. That's probably not going to be changing on 2D games because right now 2D games aren't the popular thing. That doesn't mean they don't exist. In fact, they just some company just released a new 2D game for PlayStation 4, some re-release of an older platformer or something like that. So there is kind of this throwback type of feel for these older 2D games. They're still fun to play, but it's not the cool thing that the game companies are throwing out there today. Okay, anything else different about 2D stuff versus 3D? So especially in today's world, if we're developing 2D stuff today, we don't need to pay so much attention to performance, right? Because we have the horsepower to do it. But if we go back historically, performance was always the situation because the 2D was kind of keeping up with our hardware at that point in time. But today we're way ahead of what 2D is going to really push our systems to do. Okay, so let's pop open Unity here. Get a different project open. I wonder why that's running so slow. Maybe this guy needs a reboot. Okay, so let's create a new project here. And we're going to do CSC275. Let's just call this guy intro because we'll probably end up going back and adding some other stuff. Actually, let's call it platformer. That way we can just evolve this particular one. All right, then we're going to make sure we collect 2D as opposed to 3D. And I'm going to go ahead and save this someplace that I'll be able to get to it later. So I'm going to put it in my Dropbox. Okay, so put it somewhere that you'll be able to, well, I put it in Dropbox, that way it automatically gets backed up. So if you're not currently using Dropbox, you should start using Dropbox or something like Dropbox. So Dropbox is free, gives you, I think with a CUW address, it might give you up to 6 gigabytes of space because we got enough people signed up that you get, huh? Well, GitHub is different. So GitHub is a source code management software. So you, when you're done, working on something, you push to GitHub, then you pull when so GitHub's really when you have multiple people working on a project. Where Dropbox basically gives you a folder that sits in your computer, and anything you put in there, it syncs to the cloud. But you're always working with local files. So the idea is that if you're always saving to your Dropbox folder, and then this afternoon somebody saws your laptop in half, you haven't lost anything. As long as you never close your machine when there isn't a green check mark on this guy. It's the premise of it. Where GitHub, you need to interact with it. You need to push your changes there. You need to pull updates down. It's not that they're not competitors.
So we're not sharing it just with us.
Right now I'm not. If I share it with you, I'll put it on GitHub. Yeah, I think now I get what you're asking. Yeah. GitHub, Dropbox and GitHub are not competitors. Although having said that, if I'm sharing this with you, we'll have to see how big the files are for the 2D. Definitely 3D, the files get big. So there is possibly a downside. We'll have to look at what's the best way to share it. It might make the most sense to share it with a Dropbox folder link, but we'll burn that bridge when we get to it. Okay, so make sure you have 2D selected. We'll go ahead and say create project, and let's go on our little tour of Unity here. Okay, so Unity looks like this. Over here on the, well, what we have here in the center is our scene. So think of Unity as kind of our window, like we're a director of a movie, okay? And this is our window into that movie. So right now we have this scene. I'll go ahead and I'm going to save, and we're going to save our first scene. We're going to call this guy main. And notice it's saving it into a folder automatically called assets. Okay, so our assets folder is the core folder that all of your stuff for this particular project lives in. All right, so right now we have a scene called main, and all that's on set right now is our main camera. Okay, we have a camera sitting there. Now, the stuff for 2D will look different than the stuff for 3D, and we'll see that here in a few minutes. And actually, I can already tell that 2017 looks different than the Unity 5 that came before this, so we might need to do some zigging and zagging as I'm figuring out where stuff is, but it's updates are usually pretty close, so I can't imagine it's going to be too bad. But in any case, you know, we just arrived on set for our movie. There's a camera there, so now we want to start putting stuff out there. Okay? Now, for us, we need to get something to actually show up first, because as I mentioned earlier, well, let's see if this changed. If I want to introduce somebody onto set, okay, I come over here to the left-hand side where I have my hierarchy, and I can either right-click out here to create something, or I can hit this little create drop-down. All right, and for us, we're going to be creating, for the most part, 2D objects. All right, and I want to create a new sprite. All right, and let's call this guy. I'm going to go ahead and click on my new sprite. I'm just going to rename him player. All right, now the issue we have here is we can't actually visibly see our player yet because we haven't attached an image or anything to it. Remember a little bit ago I mentioned that with 3D we get these primitives, okay, that we can work with. We have cubes and spheres because Unity was originally a 3D game engine, hence unity3d.com. All right, but they've added a whole bunch of 2D stuff to it, which has made it very viable for 2D. But you know, since we don't really have there isn't a such thing as a primitive in 2D, they probably could have faked it with circles and squares, but they didn't. We have basically an invisible sprite on here, so we'll fix that here in a few minutes. So I'm going to go ahead and I'm going to just click on player just so it's highlighted, and then over here on the right we have a couple of panels. And forget about the services panel. We want to click on our inspector. Okay, our inspector tells us here. Do you want to hit the for the lights the second from the top button? I think that should dim in the front, and hopefully these things come a little bit clearer. Is that easier to see? Okay. Because I realize the text is kind of small on Unity. There might be a way of making it bigger, but I'm not necessarily sure how to do that. I'll try to investigate that a little bit before next class, but in any case, we can see this reasonably well-ish. Okay. So up here in our inspector, it's giving us the properties of our player sprite. Okay, and our properties are we have a collection of components, is what they're called in Unity. All right. Now, every single thing that shows up on our screen will always have something called a transform, whether it's a 2D object or a 3D object. Okay, a transform is its location in our scene. Okay, so the position of our sprite initially is at position XYZ, okay, 0, 0, 0, and it has a rotation 0, 0, 0, and it has a scale 1, 1, 1. Now, for Unity, you want to think about these things as units. So now we'll see a strategy if you want to have things work to scale. We can get it into meters per second using something called delta time when we're actually doing animations and making stuff move on the screen. But for right now, think about these characteristics as units, as opposed to meters or inches or feet or something like that. So if you keep everything relative to each other, they'll all keep a relative size. So if you're thinking about it in terms of feet, if this is 2 feet and this is 3 feet, this guy will be 2 units, this guy will be 3 units. But you should stick with, in your mind, some size primitive that you can then have everything relative to. Otherwise, what you'll get into is a situation, and this is especially true when you're taking a 3D game and bringing it into virtual reality. You might think it looks great in 3D when you're just playing it as a normal, like driving it with your keyboard and mouse or something like that. Then all of a sudden you bring it in, you change the camera to be the VR camera, and you get in there and one of two things. You're either a giant among men, you're standing in the middle of the city and this is a little tiny place, or you're tiny and you have this giant world around you. Both of which actually have kind of a neat effect, but probably not ultimately the effect you're going for. So create some level of scale in your mind when you're designing your worlds. Okay, that's less of a problem in 2D. Because in 2D, we're not worried about bringing it into VR, so the way it looks is the way it looks. But as you're designing your levels or thinking about, how big Mario should be relative to the turtle, think about just having some sort of standard scale that you will apply your units to. Make sense? Okay. So over here, we have our transform. That's its position, its rotation, and how big it is. And every single thing that shows up on the screen will have a transform. Okay, the next thing that automatically comes with a sprite is a component called a SpriteRenderer. Now, notice right now, next to sprite, it says none. We don't have something visible associated with this. Okay, so we're going to want to fix this. So let's just pause this for a second, and I'm going to bring up a site, and I'm sure there's tons and tons and tons of sites for finding sprites. Okay. The one I've used historically, that's called historically over the last 3 months, is something called opengameart.org. And I think I gave you a link to it on the website. Okay. This thing has 3D stuff in it, but I've mostly used it for 2D stuff. So I'm just going to grab something. Here, we're going to do a platformer in the forest. Is that one going to be... on the internet? Let's see what the sheet gives me. Okay, that's fine what it gives me, but that's not the ultimate thing I want. I want to go to characters. This should give me what I want. Yes. Okay. So remember earlier, here, let me blow this up a little bit. Okay. I mentioned something about, what is this supposed to be, like a baby? That's going to be creepy, but we're going to go with it. So, in any case, I mentioned something about animations earlier, right? And so one thing we have when we're dealing with 2D art is a lot of times you'll have these sprite sheets. So effectively, it's a single image like this that has a whole bunch of characters on it. Okay? Now, from our perspective, we can say, okay, well, there's all our characters, but what are our options? Well, we can go in and we can cut out each of these guys. We can kind of highlight it. We can go into a photo editor type thing and cut the pieces out, right? But realistically speaking, we're looking at this. We can tell all those images are the same size. Just for convenience purposes, they're in a single sheet, right? And the reason because the reason this works this way is these are low resolution images, okay, and creepy babies, and they try to hide that. Okay, so they're going to give us our characters in this single sheet. Now Unity has built into it something called a Sprite Editor that will allow us to go ahead and automatically cut our sheet up Okay, that way we have those individual images as if we, I don't know how many are in here, but a bunch, right? Let's call it 60 images. There might be more or less, but more than 5, right? Lots of images in here. So I can individually import 60 images into my game, or I can bring a single sheet in and then let Unity slice it up. Okay, so that's what we're going to do. So we're going to bring these characters into our game. So I'll go into Unity. Down here in the bottom, now this is the default layout. There are ways that you can change your the way you want your layout to work for Unity. So if you don't touch anything, your Unity will look like this, the way I have mine laid out. So on the bottom here, we have a console, which is what will show us our error messages and stuff like that. It's similar to like the Eclipse console if you're doing Java stuff or something like that. But go ahead and click on Project. And notice this guy is going to show you the contents of your assets folder. Okay, and then over here to the left, it also shows your assets folder. Well, what I want to do is I want to get that character sheet into my assets folder here for right now. So it downloaded here in downloads. So here's characters. I'm just going to drag it in here. Alternatively, you can right click. I can right click here and I can say import new asset. And then I can go and find it. If you'd rather do that than the drag and drop method. So choose your poison. Okay, so I have this character sheet here. All right, so when I click on that, notice up here it says this is the inspector for this guy. Now he's not on the screen, but notice he has something called a Sprite Mode. If I had imported an image that represented a single sprite, like a picture of Pac-Man or something like that, I'd want this to be single. But because I know that the nature of this image has a whole bunch of sprites on it, just for convenience, it gave it to me in a single image, I'm going to change the sprite mode to multiple. Okay? Now, when I change it to multiple, let's see, I'm going to guess that our Sprite Editor is going to be in window. Let's see, Sprite Packer. That's going to allow us to create new things. Where did you see it?
Where you chose the single and multiple Sprite mode.
Oh, Sprite Editor. There's my button. Thanks. All right. So when I change that to if I have it in single. Actually, I'm surprised that Sprite Editor button was still there. But you want it to be multiple. And then I'm going to choose Sprite Editor. And it's saying unapplied import settings that apply to continue the Sprite Editor. So because I just changed it from single to multiple, it wants me to apply that. All right, so now it's going to show me this thing that looks like this. So that's like my picture, but really tiny, right? Now we have this button up here. Where's my button? Slice. All right, so I have this thing called slice, and I can choose type automatic, or you can also choose cell size or cell count. The easiest thing is when all the sprites are the same size. There is a such thing as a sprite sheet that has different size shapes on it. Then you got to get a little. You can tell it how many sprites are on there. Then it try to magically figure out how those pictures are separated. But this guy is the trivial case where we'll just let it automatically figure out they're all the same size. We can kind of see it as shown us in a little grid thing. So it's going to be automatic. Pivot is going to be center on each one of those guys. So how we're slicing it. And then method, it says delete existing. I'm not sure what that does. So I'm going to go ahead and hit slice. I'm pretty sure I hit it. Let's assume it worked. So I'm going to come down here. Do I have my assets yet? I don't have my assets. Oh, I think I need to apply. So after I slice it, I have to hit apply. There we go. And that processed my guys. And then do I have my individual sprites down here? So I'm going to hit this little arrow next to it, and notice it's now shown me individual dudes. Okay.
I have this problem with not applying anything. Can you show us really quick again?
Yeah. So I click on the image. I go to my Sprite Editor. I hit slice. Then I hit slice. And then click on this apply button up here. So slicing, it says go and figure out. So notice when I sliced it, it shows me the little cutouts it's doing for each of these guys. So now I'm saying, okay, I'm cool with that. Apply it. And now it hopefully just re-imported and didn't import them.
It does the apply, but it doesn't show them at the end.
Well, no, it'll look like this, but then there's a little arrow next to it.
Oh,
Click that arrow. That's the contents.
right, yeah. No,
You see it? Now, actually, I am interested in something real quick because I saw that arrow there initially. I'm going to go ahead. You don't need to do this. I'm going to delete this. I'm going to bring it in again. I want to see if it auto slices. I think it might. No, it doesn't.
maybe if you change it to multiple.
Is there an apply up here?
Yeah, that one.
Oh, there we go. Nope, even worse. so we'll go back into our editor. We'll slice it, and then we'll apply. All right. So we have our guys. All right. So now what we're going to go ahead and do is, I think what would make most sense for us right now, if we're going to keep this creepy, is go with the our baby. Okay. So I clicked on player. Then I, next to Sprite here, I clicked on one of my babies. We're not doing animations yet. So I just clicked on one of my babies and I drug it in there to my, my Sprite. And is this guy showing up yet? There we go. All right. So once I clicked it into my Sprite, then when I went ahead as I did, I double clicked on my the player. And that should zoom in to have a creepy baby there. All right. Now, notice that when I click on camera, just click on camera once, notice that way back there in the, you see right in the middle, there's a little dot. So the baby is coming at you and is really scary, right? And that's because the position of my camera is at -10. So it's at if I look at it on Z, so if I click on my camera, I look at its transform, its position is 0, 0, so it's in the center of the screen, but then -10 is back towards us, okay? So +10 is that way, which will make a difference in 2D from perspective, okay? But we're not traveling that direction in 2D. We're breaking the 2D rules if we're doing that. But from a perspective thing, we can, like, for instance, right now, tiny baby. All right, so let's go ahead and let's change the Z on this guy to like a -1. That did not seem to make a difference. Double click on the player. You click on player and then double click, it should zoom into the baby. Do you have next to Sprite here in the baby? Do you have a character there? Or does it still say none? And when you double click, nothing happens. Let's do this. Let's go ahead and remove the player. And I'm just going to click on the baby and drag it out here. should effectively give us the same kind of sprite. If you double click on it now, do you see the baby?
Yep.
Okay. All right. So right now our baby is really tiny. It looks like the way they've done it with 2D is the depth does not matter, which actually makes sense. So I was just saying before that depth doesn't matter. So what does this mean? If we have a really tiny baby here, that means our scale on our baby is really tiny. So if we want our baby to show up more, we're going to go ahead, click on the character. We're going to go to scale for the baby. And let's change it to 10, 10. You can actually leave the Z1. Baby isn't getting any fatter, depth-wise. Okay, so now we should see the baby more on the screen ourselves. If you click on the camera, bigger baby. Now go ahead and hit play. Creepy baby video game. Man, that baby is creepy. And it's going to be even worse when we do the animation on that thing. There should be a 2D baby zombie game. Why are baby zombies so creepy? Do you watch, what's the name of the show? The zombie... Walking Dead. Yeah, have you seen Walking Dead? There's this one episode where this lady, she's pregnant and the baby turns. It is the creepiest thing you've ever seen. Why are baby zombies? Well, first of all, why aren't there more baby zombies? Okay, secondarily, why are they so creepy? That's your next paper. Describe why baby zombies are way creepier than adult zombies. You could also at the same time explain why. So it would make sense for somebody like me, based on the personality you may be seeing, that I might enjoy zombie shows, right? My wife, which most of you have not met, is not like me. Likes Walking Dead. No idea why. She doesn't like gory stuff. She can't watch gory stuff. But she said she watches Walking Dead. She's like, I like the storyline. Yeah, maybe that's it. I don't like the more recent series. They're trying to, make a more of a story thing instead of just gory killing. I think it's maybe that's what we just did, the gender difference, right? Guys just like gory killing. We don't care if there's any story whatsoever. My wife wants it to make sense. It's like, oh, aren't you sad that her baby is just... No, it was a zombie baby that died too quickly. I wanted that thing to be roaming wild, killing people. Oh, awesome. Okay, so we have a baby in our scene right now. At this point, there's not a whole lot, there's nothing else in our scene, so we don't have platforms or anything like that. Okay, so now let's look at components a little bit more for our baby. Okay, so this guy is a sprite. I'm going to go ahead and rename this dude to be called Player again. So we're going to have the creepy baby player. That's going to be our actual player. It's going to be awesome. All right, so name this guy Player. And again, make sure you've selected the inspector. So right now we have our collection of components here, but our only components for this guy is position and the sprite renderer. Anything with the word renderer on it means make it show up. Okay, that's what renderer is. Okay, so for instance, if I wanted to make this guy invisible, I would turn off the renderer. Now he's invisible. So you see there's little check marks next to these guys. Wonder what it means to turn the... this isn't next to transform. So we can actually remove the guy from the scene if we just hit the check mark there. That deactivates him from the scene. You probably wouldn't do that, but if you were testing something and there was two elements that were messing with each other, you might just disable one of them temporarily so you can kind of focus in on what's going on with this guy. That's an easy way of kind of disabling him temporarily. But that sprite render, turning it on and off, that's not something we might want to manually do out here unless, let's say we wanted to place a boss. on the screen. So, your baby's going here and is going to fight whatever babies fight down here at the end. But maybe the boss is invisible initially. And kind of when the baby enters the scene, there's some sort of thing where the boss kind of erupts and comes up, or that's when he shows up or something like that. So in that particular case, we might want to place it on the screen, but then go ahead and turn the renderer on or off to have it start in that initial state. When we get into the scripting side of this is when we'll have the opportunity to programmatically turn renderers on and off. Okay, so there's our baby. Now we're going to go ahead and let's position the baby a little higher. Put it right there at the top, center of the screen, because we're going to give our baby some gravity. So our baby falls to its death. Zombie baby. That's going to be the name of this game, is Zombie Baby. He's creepy enough to potentially be a zombie. I think we can all agree with that. All right, so we're going to go down here. Make sure you have your player selected. We're going to hit Add Component. Okay. Now, if yours currently says something, unclick it. Hit the little X up here. So you should have an empty search box here. You can search for something, but what we're going to do is we're going to go into something called Physics 2D. Because among other things, what we've discussed is that our game engines are essentially physics tools, right? It's given us the physicsy things. So we're going to click on that. And the very top thing on here is something called a rigid body. Okay. So now, if you walk up to a real life zombie baby and you poke it, it's going to be a thing, right? All right. It's a rigid body. It's an actual thing. This guy is a rigid body. Okay. Now, if I have like something like smoke, we would see smoke in the air, right? But that's not a rigid body. If I can pass my hand right through it. Okay, so rigid bodies are things that have a physical dimension to them. They have a feel. If you pushed it, they can have a mass, but they don't necessarily have a. You said mass?
Yeah.
Yeah. They don't necessarily have to have a mass, but by default they would. So we're going to go ahead and we're going to add this rigid body to this dude. So we just added another component. Okay. And oh, they took away the button for gravity. We just have a gravity scale. Okay, that's fine. So just leave it default for now. So now we've given our zombie baby a rigid body. Go ahead and hit play, and I expect this guy's going to follow this guy. He just fell out of the sky, right? We got to get some sound effects in there pretty soon. So we. All right. Now, in the ideal world, we probably want him to fall onto something, right? In fact, if you think back to some of your old 2D games, I know some of you said you weren't gamers, but maybe a lot of us, when we were kids, played like Nintendo or something like that. So some of did you play any of those things when you were, okay, so we all had some experience, more experience with 2D games than maybe our new things like Battlefield and stuff like that. I've played some of that, I suck at them, so I use the word played like loosely, is what I do. But in any case, one thing you may have noticed is sometimes, some of those games, when you start really what we're writing here is something called a platformer. And when I say platformer, think Super Mario Brothers. So side-scrolling thing, you have dude runs to the right. Sometimes you can run back the other direction, but that's a platformer. Okay, you jump up on platforms and that kind of stuff. All right, so now what you've seen at some point, probably a good example of this. How many of you ever played a game called Mega Man? Yeah, he's a blue guy. Okay, man, like half a person said Mega Man. You're not like positive, but you.
I just remember the cow.
Okay. The original Mega. Oh, come on. Mega Man. Let's see if there's an image from like way back when, the original Mega Man. This guy. So he would be a platformer. Okay? And this is Mega Man, not the evil snail guy. How did this guy even get down there? It doesn't make any sense. He wouldn't. Huh? He grew up there? He's kind of a robot. He doesn't look like he's a grow-upper. So there must be an evil wizard or evil mechanic down there that built him. Okay. So in any case, one thing that if you've played Mega Man before, and this would be kind of the reason I bring this up for the example, is at the beginning of the game, he actually starts off in the air and drops down to the platform. So they're using gravity in a collision right at the beginning, as opposed to trying to place him directly on the ground at pixel perfect level. Because one thing you can run into is you can run into a thing where he's actually 1 pixel too low, and you create this like collision inefficiency where he's sitting there just kind of shaking because he's like constantly colliding with the platform, but he can't actually stop on top of it because he's already inside of the platform. So it's not uncommon for games to just start the guy off a little bit higher. Sometimes, like the Mega Man, they decide to make it an effect where he kind of, he drops into the scene, and he had an animation, like a falling animation, where he's like, ooh, and he dropped down, and then he was like ready to fight. Where Mario, I think Mario starts off on the ground. But sometimes, we'll have to go, at some point, we can go and look, but sometimes what games will do is they start them off above the ground, but just a little bit. Where if you pay attention when the game first starts, you'll see just a tiny drop. Where gravity took effect and you let him land onto the ground himself. So he's positioned right. Okay. And this kind of gets into some of that performance stuff where dealing with that initial collision, if he's on something that he's colliding with, can actually be inefficient. Where we'd rather it deal, when we talk about colliders, this will make more sense, but we'd rather have it dynamically land. So there's an efficiency benefit. Okay, so now I'm going to go ahead. I'm going to bring in, so these were our characters. I had downloaded another Sprite pack here called Sheet. This had like some of our platforms in it. So I'm going to go ahead and drag that guy in here. All right, it was from that same download. Remember the thing I downloaded first was called Sheet. The second one was characters. Go back to our, so Sheet here. I wonder what swoosh is. So that's for an animation for, I'm guessing, does our baby have like some sort of like force weapon?
Swoosh.
Yeah, swoosh. It's like a force weapon. Yeah, it's like, obviously a zombie baby would have a force weapon. They're like zombie Jedis in training. Oh, yeah. Okay. But I'm going to bring in the one that's just called Sheet. That has a lot of our, like, the world building sprites. Okay. And then let's go ahead and slice that up. So click on it. Go to Sprite Mode as multiple. Go to Sprite Editor. Make sure you hit apply. Once you change it to multiple, it's going to make you apply it. And ooh, this one's going to be the interesting one. Okay, so let's click on slice. Let's leave it as automatic and see if it figures it out, because notice here that they're not all the same size, right? So I'm going to leave it as automatic. I'm going to click on slice, and let's see what it figures out here. Okay, so it's got in the upper left-hand corner, guys. It doesn't look like it's gotten our platform stuff too great, but we can probably reslice that. So I'm going to go ahead and I'm going to hit slice on this, and then I'm going to hit apply. And let's go back in here. So we have a lot of individual pieces. I'm going to go ahead and click on the second piece here. And I'm going to drag it out. Can I drag it out of there? It's not going to let me do that with that. I think maybe that guy is an example of how you might use these pieces, but I don't see the rock. Is this rock? All right, so we got to go back and reslice. Let's get this guy out of there. Couldn't have made it as easy as the baby. All right, so let's open up the Sprite Editor again. Choose Slice. Let's do Grid by Cell Count. Man, what are those guys supposed to look like? I don't know how you would slice this. Like, what are these supposed to look like?
You have an example.
Back in here? Okay, so it looks like the things slice with as a whole piece here, not just the top layer. Well, no, here's just a top layer here. Oh no, that's the thing. That's the thing I had. Can you do what? Well, you can. I don't know how you can do that in Unity. Let's go back to, because what I really wanted to do initially, when I hit slice, I wanted to do automatic. Let it slice it, hit apply, which then gives me these pieces. So now I have these individual pieces, and most of them are sliced up the way they should be. Well, I want to take this one piece here, and I actually want to further slice this. So I tried to bring it out of the sheet, but it's not. Let's see if I can get it to make them individual.
Someone says there's 7 rows and 10 columns.
Oh, that's what it said to do?
Well, because a lot of people have the same issue.
Okay. So we'll do cell count, and you said 10 columns?
7 rows?
7 rows by 10 columns?
By 10 columns. And I think you have to crop up the tree away. That would.
Yeah, well, we can just not worry about our tree. But even this, seven, but now we're losing out on some of these guys.
Yeah, that doesn't completely work.
We're just gonna roll with rather than screw with this too much. We have some stuff here. What's this guy?
Do you just want that one piece, or do you want something?
Well, I prefer to have everything individually split up, but I guess the secondary thing would be, how can I get that one piece separated?
If you go back into it, I have mine where I can just manually go.
Okay. So go here, go to Sprite Editor.
And then you just move the dots.
Oh, you move the pieces around. So you do the automatic slicing first. You slice it. Then you how do I get more? Like, because I still need to slice this piece down here. And I need to slice these, okay. So let's drag this guy there. Apply. Did it do anything? And then we're going to slice again. Were you able to get it?
Well, if you want just that one piece.
Yeah, that's I get what you're saying. You can get just that one piece, but even then, we kind of want these one pieces separated into multiple pieces.
Yeah. You just have to take the time to do it. Yeah, they put them too close together when they save the sheet.
Yeah, but I mean, so how do you do more than one?
That's what I'm on. Sort of big unit.
Trim selected rectangle. I don't know what that did. We're going to make this, we're going to decide that that didn't make a whole lot of sense for our, here's platformer art. Let's give us something to run on. Yeah, this gives us something to run on. And this should be divided. Yeah, let's do this. We're going to still use our baby though, not these aliens. Well, maybe these can be like enemies. Okay, so we're going to platformer deluxe graphics. Oh, we're done, right? 2 minutes ago? Okay. All right, so let's see what, I don't think we can actually do anything yet. We are going to be doing a platformer in here initially. So if you want, I mean, our in-class example looks like it's going to be Baby Zombie. But if you want, you can go ahead and find a different art pack that looks the way you want it to look. And hopefully we'll get some animation and get him dropping onto a platform and movement on Tuesday, and then we can incorporate that into our games. Okay? All right. I'll see everybody on Tuesday.